AP Cram, Calculus AB, Free Response Exam Review. Question 33, Slope of a Tangent Line. The function f is defined on the closed interval -5, 4. A closed interval always includes the endpoints, that's why it's denoted with a bracket. The graph of f consists of 3 line segments and is shown in the figure. Here goes line segment 1, line segment 2, and line segment 3. Let g be the function defined by g of x is equivalent to the integral from x to -3 of f of t dt. So g of x would be the integral of this function. Let the function p be defined by p of x equals f of x squared minus x. What you are to do is find the slope of the line tangent to the graph of p at the point where x is equivalent to -1. Okay? All right, so I'll give you a moment to figure that out. All right, so in order to figure out this, riddle, we obviously have to find the slope of the tangent line, but finding the slope of the tangent line at a particular point is code word for finding the derivative. So what we're going to do to find the derivative p prime of x is apply the chain rule. So we get, we're first going to take the derivative of the outer function. And obviously the outer function is f, so f prime times the inner function, and then multiply the outer function, the derivative of the outer function times the inner function, and then we're going to multiply that by the derivative of the inner function. And of course, the derivative of x squared minus x, if you take the derivative of each term, is going to yield 2x minus 1. Okay, so that's where that comes from. Now we need to analyze our derivative with the initial condition that x is equivalent to 1. Because, again, finding the tangent line at the point -1, not 1, I said 1 previously, I'm sorry, is the same thing as finding its derivative. So p prime of -1 is going to be f prime, and all we did here is plug in -1. So -1 squared is 1, a -1 minus, okay, and then minus a -1 is going to be like adding 1, so 1 plus 1 is 2. And when we plug in -1 here, we get 2 times -1 is -2 minus 1 is 3. So f prime times 2, or we can consider this f prime of 2. Well, in order to do that, we just can look at the graph of f. Although this is not the graph of f prime, we can go to the location where there's a 2. And again, finding the derivative is the same thing as finding the slope at a given point. So we can just approximate the slope right here. So our first point, y1 and x1 is going to be, x1 and y1, I'm sorry, is going to be 2, 0. And then we can use this convenient point down here, 4, 4. So we know that the formula for our slope is y2 minus y1. Our y2 is going to be -4, and our y1 is basically 0, so 4 minus 0 in the numerator over our x1, which is 4, and our x2, which is 4, and our x1, which is 2. So -4 minus 0 in the numerator is going to give you -4, and 4 minus 2 in the denominator is going to give you 2. So negative 4 divided by 2 is going to give us a negative 2. All right, so that's where we get the negative 2 from, because we analyze f prime of 2, and then we just carry over the 3. So our negative 2 times 3 times negative 3 yields us 6. So the slope of the tangent line at x is equivalent to 1 is going to be 6, or p prime of negative 1 is 6. Again, we apply the chain rule. So the chain rule states that we take the derivative of the outer function, f prime, and then, we just write down the inner function, and then we take the derivative of the inner function, okay? And then we plugged in the initial condition that we were given, and we broke down f prime of 2 by looking at this graph for the tangent line or the slope. So this might be a little uncomfortable for some of you. It's okay. Just do a few more of these examples and you'll feel more comfortable. So it's okay if it seems a little hazy now. That's totally normal. All right? Okay.